Hello guys, in this video I'm going to show you how to solve task scheduling problem. So this one is in topological category. There are n tasks labeled from 0 to n-1. Each task can have some prerequisite tasks which need to be completed before it can be scheduled, given the number of tasks, and list the prerequisite pairs. Find out if it is possible to schedule all the tasks. So we have two examples here. First one is we have total 3 tasks, right? So they are 0, 1, 2, right? So we also given a list of prerequisites, right? So 0, 1 means to complete 1, then task 0 must be completed first, or 0 is the prerequisite of 1. Same here, we must complete 1 before 2 and 2 before 0. So it is pretty obvious that we couldn't schedule all the tasks, because as you can see here, 1 depends on 0 to 1 depend on 0 to be complete. 1 depends on 0 to complete, right? Again, 2 depends on 1 to complete. But this one will cause conflict because 2 again depends on 0. So we have a circular dependency here. And 0. As you can see here, as you can see, 2 here is again the prerequisite of 0, right? So it creates a circular dependency that we couldn't schedule tasks. So that we couldn't schedule all the tasks, right? So, but for this guy, it is obvious that we can schedule 0, then 1, then 2, right? So the point here is to recognize it is a topological pattern, and we must how to say, we must model the problems into a graph, right? So each task will be a vertex in the graph, and the edge will be directed edge, right? So for example, we have an edge from 0 to 1, 0 point at 1. It means node 1 depends on 0 to complete, right? So 0 must be completed before 1 before we start schedule 1, node 1, right? So it is pretty much it about this one, about this problem. The most important thing is to model it into topological problem. So when we can recognize the pattern, it is 99% same as our previous one, which is topological sort, right? So here we have a couple things to do. First thing is to build our graph, right? To build the incoming and incomings. We need to store the incoming or the dependency, the number of dependency of each task, right? So we save it in a map. So for example, a task A have 3 dependency, task B has 0 dependency, for example. So we store the number of dependency for each task. View incoming. Right. Okay, so our output here is just true or false, which means whether we can schedule, we can make a schedule for all the tasks, right? So it's different from the previous one, right? In the previous one, we have to print out the sorted order, one possible order. So how to check if scheduling is possible? So it's simply by, we also need to create the order list, right? So when we have a order list of tasks, all tasks that is scheduled, let's call it order list, right? So when we finish scheduling into this order list, we probably want to check if this list contains all the tasks. So we return order list dot length, check it if that equal to number of tasks, then it means everything is scheduled. Then the answer is yes, we return true. But if this is false, it means our order list size is less than the total of tasks. So it means we couldn't schedule all the tasks, right? So let's build a graph first. Cons graph. Want to use a adjacency list here. Okay, incoming is also a map between a vertex, a task, and number of dependencies. So we first initialize the graph in incomings. So for let I go to 0, then tasks. Task here is number of tasks, right? So if we have 5 tasks, for example, I will run from 0 to 4. So it also denotes the task itself. So we have task 0, task 1 to task 4. So graph, let's say I'm gonna set the task 0, and the value is an empty array, which keeps all the destinations of vertex I, of task I, right? Incoming, I'm gonna set the vertex I with 0 value here. So now I'm gonna run to all the prerequisite. Let pair of, so the prerequisite will be the list of arrays with size 2, where first number is the source task and second is destination task of prerequisite. Okay, I'm gonna destructuring this to form into. Okay, so I'm gonna get from the graph, the destination list of tasks from, right? So this will return a list. So I'm gonna push the destination, let's call it source and destination, source, and push the destination task in, and also I'm gonna build the incoming by set the incoming. I'm gonna set for the destination task, right? Destination task. I'm gonna set it with whatever value it is right now, +1, right? So after these two for loop, we will have graph and incoming build. So the next step is to the next thing to do is we need to keep all the possible tasks to be scheduled into a queue for later processing, right? So same as the topological sort, right? Heap, we need a queue, right? We need a, let's call it sources. Stored in a queue. Oops. Okay. Queue sources will store vertex dot task that have no dependency, right? So we first initialize it with all the tasks that has no dependency. So that all the tasks with no dependency will be scheduled first, right? I'm gonna run through the incoming to check all the tasks with no dependencies. For letter, gonna loop through a map. So we have key and value. Key is a task, and value is a number dependency. Depth of incoming entry. Okay. So if the number of dependency of current task is 0, then I want to add this one to the sources to be scheduled first. Add task. Okay. So now we start scheduling. So as long as the sources is not empty, which is the length is greater than 0, we want to do a couple of things. First is to take out the next task to schedule. Okay. Schedule it by adding to order list. After schedule the current task, we want to update, right? Update our incoming lists. Also, if incoming map, incomings, if one vertex, if one task update will decrease by 1 because the current task is already scheduled, so we don't care about all the vertex from that vertex from the task, right? So we want to decrease by 1 all the vertex that are coming from the one that has been scheduled, right? -1. If one task dependencies reach 0, we want to push add that task to the source queue. For later process. Okay. So firstly, we take out the next task schedules. Okay, we start in task out equal to sources dot ship a to d queue from the sources queue Okay, schedule it by adding the orderly. Push the task out into how to update the incomings. So we want to update all the tasks. That's starting from this one, the task R, right? So in order to do that, we wanna get access to our graph, right? Access by key, then gonna have all the destination tasks of task R. Then we run iterate to the destination task. Then decrease incomings by 1 for each of those tasks, right? So wanna run for let what is that? Dash, let's say dash of graph get task out, right? So for each destination, we want to update. Let's copy this slide. We want to update the incomings of destination task to whatever it is right now, -1. Okay. So down here, if it reaches 0, if incoming get destination, if the dependency of destination task is 0, then we're gonna push to the sources to process add to that. Okay. So after we update incomings, again we come back here, start another iterations, take out, push to the order list, and again updates the incomings map, right? So we exit when there's nothing in the sources. So if the order list is of size tasks, same as the number of tasks, then return true. So let's run a test. Okay, this works. So thanks for watching. See you in the next video.